Well, welcome back to our course on algorithms and data structures. We're continuing in our process of introducing these various data structure types. We've talked about the bag, we talked about stacks, we talked about queues, when we talked about list. And now, before we get into the next things, when we get into some of these useful techniques, we'll have a Java interlude, and then we'll talk about a little bit more about iteration. So first, let's talk about iterators. And so for this Java interlude, let's focus on these are the topics that are in this chapter, but let's focus on what is an iterator, and we'll dialogue about this in a few different ways. And so an iterator is an object that traverses a collection of data. During the traversal, you can look at the data entries, modify them, add entries, and remove entries. The Java class library contains two interfaces, iterator and list iterator, that specify methods for an iterator. While you could add these iterator methods to an operations of an ADT, you should instead implement them as a distinct class that interacts with the ADT. The iterator class can be outside of the ADT or hidden within its implementation. We'll explore both of these approaches in this interlude and in the next chapter. So as you can see, we'll be talking about the interface iterator and the interface list iterator. So in a little bit more details, what is an iterator? So how would you count the number of lines on this page? You could use your finger to point to each line. As you counted, your finger would keep your place on the page. And so this is from the Java overview that we have mentioned a couple times. And so you can use your finger could keep your page on the page, place on the page. If you pause at a particular line, your finger would be on the current line, and then you would be a previous line and the next line. So all those things are things that we have discussed before. So an iterator enables you to step through or traverse a collection of data, such as a list beginning with the first entry. So you're able to traverse a collection. During iteration, each data item is considered once, and it should implement as a distinct class that inherits the ADT. So those are some of the things that we just wanted to point out. So here is the interface iterable. And so different ways of obtaining an iterator for given collections are possible. One way is for the collection itself to create and give you such an iterator, a class that implements the standard interface Java.lang.iterable is shown here in the listing, can do this. The interface declares only one method iterator, which returns an iterator that adheres to the interface iterator. We will use this method in the examples that follow. And so here is the listing, and an iterator marks its current position within a collection, much as your finger can point to an entry in a list or to a line on this page. However, in Java, the position of an iterator is not an entry. Instead, it is positioned either before the first entry in the collection, between two entries, or after the last entry, as we are showing in the figure illustrates. For a collection of n entries, a cursor has n+1 possible position. The next entry in the iteration is the one right after the position of the iterator's cursor. The method hasNext sees whether a next entry exists and returns true or false accordingly. So here we'll get into more details about the Java interface iterator, and as long as it hasNext returns true, the method next moves the iterator cursors over the next entry and returns a reference to it. As parts A and B of the figure here illustrates, repeated calls to next traverses through the collection. As the iteration progresses, the iterator returns entry after entry. Once a next has returned that last entry in the collection, a subsequent call to it causes a no such element exception. So here is the interface iterable. The different ways of obtaining an iterator for a given collection are possible. So we already mentioned this. So here we're just showing the interface and the high level code for that. So using the interface iterator, some details of using the iterator depends on the iterator. Some details of using the iterator depends on the approach used to implement the iterator methods. The next chapter will explore these approaches. For now, we assume that the class that implements an ADT has a method that returns an iterator to the ADT's entry so that we can focus on how the methods in the interface iterator behave. So here we'll walk through an example. So let's look at an example of how the method hasNext and next of the interface iterator works with the ADT list. Suppose that our list interface extends the interface iterable and the class myList implements list interface. So the following statements create a list of names which are simple strings. So basically we have list interface string name list equals new myList. And so name list add Jamie, name list add Joey, name list add Rachel. At this point, name list contains a string Jamie, Joey, and Rachel. To get an iterator for name list, we can call name list method iterator as follows: iterator string name iterator equals name list dot iterator. The iterator name iterator is positioned just before the first entry as we're showing in the figure, and illustrates a sequence of events that demonstrates the iterator's method. And so we go through one at a time each of these elements. So as we continue on, we can use an iterator to display all the entries in the list. The following statements, they're a list. We'll get to the statements a little bit later, and they're also in the textbook. Display the strings in the name list. We first create an iterator object by invoking nameless method iterator. The resulting iterator name iterator is positioned just before the first entry in the list. Therefore, name iterator.next will return that first entry and advance the iterator to just before the list second entry. As long as hasNext returns true, next returns the next entry in the list and advances the iterator. Thus, every entry in the list is retrieved and displayed. So as an example, the interface iterator provides an operations to remove an entry from a data collection. This entry is the one returned by the last call to the method next. Thus, you must invoke next before you can call remove. Suppose name list contains a string Andy, Brittany, and Chris, and a name iterator is defined in the previous example. So in the figure where it illustrates the behavior the iterators remove, such as an iteration of name list. So you can see how we take out a name on that list. What about multiple iterators? Although the previous example showed one iterator traversing a collection, we can have several iterations of the same collection in progress simultaneously. For example, imagine a printed list of names that are not distinct and are in no particular order. Running one finger down that list to count the names is like having one iteration of the list. Now suppose that you want to count the number of times each name occurs in the printed list. You can use two fingers as follows. Your left hand uses one finger to point to the first name in the list. With your right hand, you use one finger to point to each of the names in the list, starting with the first one. As you traverse the list with your right hand, compare each name to the name that your left hand marks. And this way you can count the number of times the first name occurs in the list. Now move your left hand to the next name of the list and use your right hand to point to the beginning of the list. Repeat the previous process to count the number of times that the second name appears in the list. So try it if the names in figure J4-5, as we were showing in the figure here. Since your left hand will encounter Jane 3 times, you will repeat the computation needlessly unless you are careful. So that's just something we'll talk about a little bit more later. So let's show some code that counts the occurrences of each name shown in figure J4-5. Let name iterator correspond to your left hand in the figure. Now we'll define a second iterator counting iterator that corresponds to your right hand. For each name that your left hand marks, your right hand traverses the entire list to count the occurrences of the name. Thus, we have the following nested loops, assuming that the name list is the list. And so that's what we're showing here on the slide. So in this figure, we're talking about the interface list iterator, and the Java class library provides a second interface for iterators, list iterator. In this packet, in the package Java util. This type of iterator enables you to traverse a list in either direction to get the iterator's current position and to modify that list during an iteration. In addition to the three method has next, next and remove that the interface iterator specifies, list iterator contains methods such as has previous, add, and set. Like iterator, list iterator positions an iterator's cursor either before the first entry in a collection, between two entries, or after the last entry. And so we're seeing this in the listing. And this is just more of that. And you can either look in the textbook or review these notes at your leisure to go over that in more detail. So let's talk about the previous entry. And so list iterator also provides access to the entry just before the iterator's position, that is the previous entry. The method has previous sees whether a previous entry exists. If so, the method previous returns a reference to it and moves the iterator's cursor back by one position. As we're showing in the figure, the effect of the previous on the list intermixing calls to previous and next enables you to move back and forth within the list. If you call next and then call previous, each method returns the same entry. Like next, previous throws an exception when called after it has completed its traversal of the list. Let's talk about the indices of the current and previous entries. In this figure, it shows the methods next index and previous index. Each return the index of the entry that a subsequent call to the next or previous respectively would return. Note that the iterator numbers the list entries begins with 0 instead of 1, as our ADT list of operations do. The call to next would throw an exception because the iterator is at the end of the list. Next index returns a size of the list. Similarly, if a call to previous would throw an exception because the iterator is at the beginning of the list, previous index returns -1. And to finish up here, the interface list revisited, the interface Java util.list that we described in segment 1014 of chapter 10 extends the interface iterable. So it has the method iterator. Additionally, list declares the following methods related to iterators: public list T list iterator and index, and public list iterator T list iterator. Each of the list iterator methods returns an iterator whose methods are specified in the interface. List iterator, the iterator returns by the first version of list iterator begins at the list entry indicated by index, where 0 indicates the first entry in the list. The second version of this method has the same effect as listed iterator 0. Because of the standard classes ArrayList, LinkList, and Vector of the package java.util implement the interface list, they have these two list iterator methods as well as the method iterator. Okay, that concludes our short Java interlude. Thank you very much.